static, quality, application criteria that you understand better how to choose the right system for the application. And this, of course, is focused on pressure pipe application. When we talk about water pipes or other pressure pipes, I don't talk about gravity or non-pressurized pipes. So this presentation is about the application design of pressure pipe lining. So yeah, how it all started? It's quite interesting. Actually, I've been working many years ago with a company. Therefore, the picture is from Japan. So interestingly, the idea to put a flexible textile hose lining into the pipe comes from Japan for pressure pipe systems. So Japan, as you all know, they have a lot of earthquakes, or they have seismic conditions. And every time they had an earthquake, the pipe leaked at joints, the gas pipe many times. That's where the idea comes from. What you see here is an application of a textile hose, woven, circular. So there's a polyester yarn woven, like your textile basically of your clothing, it's similar like that. And they put it with resin inside and bond it into the pipe. So what you can see here is, I just try to give you an image. So when the pipe is new, everything is fine. And they have put the lining in there, and the lining was kept flexible. So when you have a earth movement, the lining will make sure it stays inside the pipe, bonded to the existing pipe, and it bridges over the joints, so the joints will not be leaking anymore. So that's where the entire idea of pressure pipe lining actually comes from. Yeah? Oh, yeah, no. Okay, so, and then you have an evolution of these systems. As I said, it started with circular woven linings. Then companies started to develop more rigid, more thick systems to make it more like a pipe. So the first idea is I bond the lining inside, make it leak-proof, and then they moved into making it thicker to have it more like a pipe inside the pipe. There you have felt glass linings, which were developed already 25, 30 years ago. And in the last, I say in the 20s, but okay, a little bit more of 10, 12 CRPP linings now. So the pictures, what you can see is that we talk about trenchless. Important to understand this. We make one pit where we open the pipe on one location, and then we insert a system over 200, 300 meters. And we have an end pit, and there we are closing the pipeline again. So everything in between today is a new pipe. That's what we are talking about. So we have a flexible lining with resin, we put it inside, we cure it with UV light or with heat, and it becomes a new pipe. In our case, a full glass lining solution. But my dear friend Werner is still talking a bit more about it in a moment. Yeah? So, and here you can see it in terms of properties. So the first lining is just, as I said, a bonded lining, a flexible tube bonded inside the pipe.
Direct.
The second step was then to make it more stiff, more rigid, like a pipe. And the third step is just to have it as a pipe inside the pipe. So if you have a PN10 pipeline, 10 bar operating pressure, you design your CRPP lining like a PN10, 10 bar pressure rated system. And you put it inside, and that's it. And you can forget about your old pipe. Why do we do that? Signal microphone. No? Hello? Yeah. So, okay, I speak like that. I think you can hear me anyway. The room is small enough. Okay. Yeah. Lights on, but the one. Okay. I think mine was loud enough, right? Okay, good. Then I continue in the meantime. Oh, now the unit is off as well.
Then I wait because of the translation.
And I wait for the translation. Okay, good. He's still talking. Is it good now? No, it's not.
No. It's still keeps signal.
I'll use also the break time, so no problem.
Okay, no.
Okay, you can be here until 4.
Mark, somebody is still talking. I don't know what he's talking about. Of course, you can use the same. Actually, the system of course comes from a non-pressurized. But if you want to understand it all a bit more about, especially non-pressurized pipe, then you wait for Werner. So Werner will tell you about the full range.
Actually, the technology itself for pulling something in and have a new pipe, old pipe is for both. It's just the product, the making of the product, the fibers are different. But actually, the idea of having, let's say, 200 meter, 1.1 point, go through, make it in a day's time, new is safe for any medium.
اسمع له يكون في فيوز ما في جهاز ثاني يستخدم فيه انا جاهز لازم يشتغل وين ايش في بالشارع؟
So for the newcomers, I think we don't need a translation for this. Our first presenter is from IVG company, presenting the CIDP trench solutions, especially for pressurized pipes. We will have 3 presentations in this session. So because of this delay, we may use also the break time after the session. So we may remain in this room until 4 p.m.
Sounds like we have a Hello?
Okay, let's try.
Hello?
خلاص خليها علي
Yeah,
Can you hear me now?
Yes.
But not here, not the loudspeaker, right?
No.
You can hear me? Okay, now we're back. Good, okay, very nice. Thank you. Okay, good. Then please use our time. Yeah, pressure pipe is a living subject. That's very important to understand, as it has a history. We spoke about gravity pipes. It's a bit more simple, but when we speak about pressure pipes, things are moving. So you have pressure cycles. I mean, you have super pressure pipes, which are worse. You have heavy pressure cycles, but also water. You have higher loads, you have lower loads. So there is dynamics in the system, and you have to allow for that for your design. So therefore, now you have quite a good ISO standards available, as I mentioned there, the 295 up to 298 for the various systems. You also have testing methods for long-term failure pressures and things like that. They do exist. So what I want to highlight on is that you make sure before you're using a system that it is being properly tested and then designed for. So what I mentioned there is in the lower part is that you have to watch out for the pressure hammers that you may have, and you watch out for dynamic stress loads, cascade, ramp, pulse cycles, rapid changes in operating pressure, or even peak stress points. What that means is, because our lining is flexible, it goes in the pipe, and it will follow the pathway. So if we have a bend, or you have displaced joints, so there are a few situations. The pipe is not always straight, especially on the water systems. You have done repairs before, maybe you had a cast iron and you put a section of plastic pipe back, so you have a little slight change in diameter. So water pipes are quite difficult to rehabilitate actually. It's more difficult than ceramic pipes. So we have to allow for all these situations in your design and in the analysis. So I just illustrate here an example. It's a bit simplified, but imagine internally, if you have a PM10, a 10 bars operating pressure system, you may imagine that the pipe is 8 meters deep and has, just as an assumption, an 8-meter water table. So the pressure from the outside, the load, and even the earth's load, everything is rather low compared to the internal load. So the internal load is much, much higher. And when you look at the graphic there, you can see that when you design a system, mostly in the higher pressure rating, so the defining property is of course your hoop stress, or your tensile strength in the system. I think it's off again.
No, it's fine.
You hear?
Yes, we are hearing.
You hear?
Yes.
Okay. So, but I think the mic was off. Anyway. Hello? Oh, no, it's back. Okay, we found the plug. So, that is very important to understand. Yeah, and there are now there are new methods, new standards available to design pressure pipelining properly. I give here you an example. Actually, there is even standards available. Because how do you test the quality of the system when you have installed it? So the ASTM 2290 method, for example, gives you the possibility to understand what you basically have installed. So one of the messages I really want to convey is, how do you know what is in the ground later on, as an engineer of a water company, for example? So that is very, very important. So here you have a method, for example, when you install the lining, and the lining will always be a bit longer than the pipe. So you cut the end off, and then you close the pipeline. So you have always a piece of material available. You can take out, bring it to a laboratory, and you can test it. And this method here, this 2290, for example, gives you the possibility to test the material under kind of live condition to see, okay, what is the strength of my new pipe, what it basically is in the end. So you have a chance to do that, but to make sure to invest the money for the right thing. That's of course important for you. Here is another example of tests being available. The 15306. The lining material is being tested under dynamic conditions. So, as I say, the living thing of a pipeline, pressure goes up and down, up and down. In certain conditions, you may even have vacuum occasionally in the system. So, how do you determine that your pipe, basically, what it is in the end, is strong enough to absorb all these loads? And there's testing available over 10 million cycles. It goes up to 10 bar and minus the vacuum 10 million times at 2 hertz. So to test the material over long-term condition that is suitable for dynamic pressure pipe application. Yeah. So same thing. Here is also important your long-term condition of your new pipe which you put in the ground. The inner surface, because we have a composite structure. Composite structure means we have a glass material. Yeah, it's a full glass, high strength material. But internally, the system is supposed to be having a strong inner surface. Yeah, or at least, for example, 1 millimeter PE coating with an epoxy layer, which is this system here from IBG. So this is being tested as well with 100,000 load cycles. So to test the internal surface of wear and tear resistance. I mean, in water usually you don't have solid content, but you still need to make sure that over long term your pipe on the inner surface is performing, because there are certain installation conditions. I don't want to go into detail for that, it will take too long, but you need to have certain material conditions to be able to install it. So, and to make sure that the internal surface is then the end product. So that's not as easy as it sounds to do, but we have to make sure that this is the case. That people, what I'm telling you is that people have these tests for you available. That you understand, okay, if I put that in the ground, it performs like pipe over at least 50 years. And you need test results like that as proof. This is a system. You have a full glass structure. Yeah. So internally, we have a 1 millimeter polyethylene coating. Yeah, which is brought inside and bonded with an epoxy layer. Yeah. So that is a full system.
If you want, we can.
Yeah, maybe you can have a, if you like. So,
Or you can show slide the picture of the.
It's better sometimes to touch.
the picture of
Yeah, it's like for example
our system.
the components of this, the components of this material of this piece. Can be shown.
It's not in that presentation.
If it is available, sorry.
It is available. So if you like to give me your card, I'll send you this information. Or the person sitting behind you can do that. Okay. So, okay. Time is critical. What I'm saying here is key criteria. If you go through this list, so if you are making sure as an engineer, you follow all these conditions. The mechanical properties, external and internal loads, the long-term factors, the tensile hoop stress, dynamic loads, abrasion resistance, and so on. So this is the list you should manage. You have in your specification, and you need to ask the contractor who wants to put the system into your pipes to provide you all of these test reports and specifications for the technology being put in the ground. So that's important. Yeah, so the design is one thing, but what was designed? And that you can only find out when you look and study the documents, and after you have installed the system, you check it physically. All that has to be done by the engineers. One important thing for designs, as I talked about the evolution of linings earlier. Okay, question?
The working pressure.
Yeah.
Up to
60. Operating pressure. Operating pressure. So that means if you have a 16 bars operating pressure, we designed the system for 16 bars, but for you in theory, the factor is about 4. So when you have a 16 bars designed system in your ground, it's times 4 what the properties will perform. Okay? So and testing is 1.5 usually, like for pipes. It's like a pipeline. Yeah. So that's the standard factor. Yeah?
Okay, we will receive the questions after the presentation is done.
Okay.
You have one? Oh, go ahead. Fine. You have a question? Okay. So, bonding. Bonding is also very, very important because you put a new pipe in the ground. If you would have bonding, if you would bond the system onto the existing pipe, all your design assumptions and your engineering would not work anymore. I try to visualize it here. The second page will show you how that works. If you have the lining bonded onto the hose line, that means there's no barrier. So all the peak stress, if your existing pipe is having a problem, a crack or a serious problem in the joint, at that point, only at that point, the liner will need to take all the loads. You see that on the red spot up there, visualized. So you have to make sure when you put a lining in the ground as a new pipeline, you need to have a barrier. So there must be a plastic around the new lining to separate actually this new system from the old system. That your pipeline will work as an independent pipeline. Otherwise it will not work. And what I do now, you see here, that's actually a live study done on a pipe by finite element method. So you can see there, and the lining is not bonded. Yeah? So you see that for you on the right side. Yeah? So you see that the force, the hoop stress, the tensile force, is more or less evenly distributed around the pipe. On the left side, everything is blue. That means low forces because the lining is bonded. But one small point, you hardly can even see that. But all the force is going at one point. And I can tell you one thing, if there is a new system in the ground and it's bonded, and your existing pipeline is still having a problem somehow because some of the internal pressure is going to be transferred to the host pipe because the material has a bit of an expansion ratio. Your existing pipe breaks, your lining will break if it is bonded. That's important to understand. Always make sure when you put the system in, you have to have a barrier between the new system and the old system. Oops. Okay. So, the last criteria is the installation. So when you install systems, make sure you have professional equipment with a professional company giving to you even before. The same thing as for the material is for the installation. You have equipment like that available, controlled by PLC, controlling all installation criteria. Speed, temperature, timing, all of that has to be controlled, put on record, given to you. If you install 300 meter of pipeline, then you're going to receive a protocol, which is an automatic record of the data of the installation. So that you understand, because in the end, what do? We are producing a pipe inside the pipe. It's like a pipe manufacturing on the ground. Yeah, if you go to a pipe factory, what do you see? You see modern equipment with a screen and controlling all the properties. We have to do the same thing on the ground. So here's just a picture of the processing equipment. So yeah, we talked about epoxy resins before. So there are now systems available. They do an automatic processing of the resins, inserting it into the lining, impregnating it. All is done automatically. And here is interesting fact on the equipments. They can even be online, connected to our company or to your office. So when you install a system, you can actually have in time the data on your computer to see what the guys are doing on site. So the equipment, you see all the graphs telling you the timing, the different temperatures, at the beginning, at the end, the pressures of the installation, of the curing. So all of that is put on record. And if you like, you can have an online connection and see it in time. It's all available today. So another important criteria is when we talk about pipeline, new pipeline, what do we do with the end? So there are methods now, as you can see on the picture. Before you put the lining inside, so you see a pit here, typical working pit of a larger diameter. That's a diameter 800 water pipeline. Yeah? So the end of the installation is done with a new section of pipe. So you put the new section of pipe in front of the old pipe before you install the lining. See actually a pointer on it? Okay. So you see on the left picture first, you see that the red part is holding the new pipe section, which is only half a meter of new pipe. And then we insert the lining, yeah, and we finish or we cut the new lining inside the new section. So anyway, and the middle picture shows you, of course, there's internal coupling available, sitting inside the new pipe section. And the last picture on the right side is just shown how to close the pipeline. So you make your cut every 300 meter, you make a new half a meter pipe section, and then you insert the lining over 300 meter, and then you are closing just these 2 meters, which was being taken out before in the installation pit. So you put a new pipe in and close the pipeline. So the result is everything is new. You can forget about your old pipe. Your old pipe is not in contact with anything anymore. So that's the basic idea. Because many people who have seen lining before, they think that some kind of material is being inside the liner, inside the pipe, to improve the pipe or to have a better surface or things like that, or to make it leak proof. What I'm talking about is a new pipe now, from beginning to finish. So a second option is even, as our material is GRP, so you can even make GRP endings. So instead of having a new pipe end, you can install pre-manufactured GRP flanges onto the end of your pipe. You have these two options. So make sure you have a new pipe all the way connected to your existing system. Okay? So basically that's what I said already. Yeah? Well, you have to go through. You check all the material sources, you check the documents, you ask for a submittal of everything. Then the type test is something I can recommend to any authority. Because if the system is new to you, how do you determine what people are offering you? We have that now in many cases, called type test. So it's in the tender specification. Before you issue a tender for rehabilitating your pipeline, you ask the contractor to offer the system, but before they start, they are obliged to do a type test. What does it mean? A type test is they do with the equipment on the ground, an installation in front of your eyes, and you can take the samples and give it to a laboratory and see if that what you have been offered is really provided. Yeah? So that's very important. So in the sample testing I spoke about, so make sure you take samples of every system, put in the ground, and this presentation basically is the guidance how to do it. So you just look at the standard, you take it out, you test it in the laboratory, and you can make sure, okay, what people have offered to me was installed. Why I'm saying it is very simple, because pipes, every water authority, every engineer, they understand pipes. It's not difficult because pipes have been around for so many years. All engineers now, they know the documentation, they know the pressure rating, they know the different materials, PE, GRP, ductile iron, whatever. So they understand. But understanding aligning is a bit more difficult. So that's the entire point I'd like to make this. It's not as difficult as it sounds. It may be new. But system standards, engineering is available to determine the lining, pipe and pipe lining in the same way as a other PE or GRP pipe or whatever. So that's it. Thank you very much. And you? Any questions?
Let me thank you for your great presentation. Because of the time planning, I suggest to receive all questions after completing the presentation because we have limited time. So today we have 3 presentations. The first 2 presentations are trenchless renovation, and the third presentation is trenchless installation. Please do not forget your questions, take your notes. After all presentations are completed, we will receive your questions. So the second presenter is Mr. Werner Reiner from Day1 Europe company. So he will be also presenting the trenchless renovation solutions, again focusing on the CIPP technology. So please.
So, distinguished guests, ladies and gentlemen. Oh, sorry. Distinguished guests, ladies and gentlemen. I know that the first 5 minutes of any session is the one with the most attention, so I like to use that. If I forget anything, here is the director of ISKI, Istanbul government, where we are in a frame contract since many, many years. So, you know, a presentation is always from a company to tell everything good about the system. After the session, you may ask him about the reality. We are also in Doha, in Qatar, since many years in frame contracts with lining works. Now, I start with the end first. What do we get? We get a new pipe in the old pipe. Small diameter, large diameter, up to 2.10 meter. You know?
If you stand
Yeah, yeah. So, it's on? It's on?
Yes.
Yes.
Yeah. So you get a new pipe in your pipe. After the lining, after the lining, the old pipe is like a soil. It's no more relevant. That is what Lutz explained before. That is designed completely as a new pipe. The advantage is you get a pipe which has no more seals, connections. It's seamless over hundreds of meters. And a huge problem nowadays is the connection and also the corrosion and the cracking. So what do we want to achieve at the end here? A pipe which is stable, which is tight, and which is long-lasting and non-corrosive with the medium. That is actually what we want to achieve. This is what you get as a result of this lining work. So we are a group of companies. We do per year about 1,000 kilometers of material supply and equipment supply in mainly sewer, also in pressure pipes, in diameter 150 millimeters, so 15 centimeter up to 2.1 meter. We go into sewer and stormwater pipes, which is because of the environment concern, actually a very big demand worldwide. And this UV cured systems is actually at the moment worldwide the leading technology doing such renovation. We go in collection pipes also, and we go in in-house up to diameter 800 into water pipes, but in a combination with IBG, we go up to 2 meter also in the pressure pipe. Pressure pipe can be sewer, can be water. So the system is trenchless. This is what Yassin said, the trenchless technology group, which means normally no excavation. We use existing access points like shafts. In the pressure pipes, we need a small pit every few hundred meters to get access to the pipe. Just
It's running.
Yes, it is.
Was running?
It's
Running.
running.
No one?
No, keep it.
Give
No,
it?
no, no.
Just wait to end.
Gehen wir noch eins zurück.
Follow this.
Noch eins zurück.
Go previous until.
Dann nochmal, genau.
Yes. Go
Gehen
previous.
wir zurück. Genau, jetzt los.
Yes.
Alles gut.
Okay. So, what we do, not we, our local contractor actually. They use the accepting points. We have a pre-manufactured product, which is glass fiber and resin, soft, which is pulled into the pipe. This is the soft material as it comes from the factory. This is a soft material as it comes from the factory. It's pulled through. Pulled through, cut on the length, inflated with a compressed air to close fitting as the size of the pipe. Then we pull a light train in, and the light cures the material. Speed is very fast. Normally day rates are 150 to 300 meters a day. Next. So, if you put this out in the sun, the soft one, 5 minutes. Now 3.5 minutes. It's out. Actually, this is I did in the morning. This is the hard side, and this is the soft side. The same sample you had before. That means a normal team in diameter up to 300-400 millimeter has a performance of about 4 kilometers a month out of, let's say, 150, average 80 meters a day. Depends on the location. You know, this is actually the rate we achieve in Istanbul with one crew, about 8-10 people, roughly. In a diameter 1.5 meter, weekly performance, depending on the location, 300, 450 meter, roughly. The same would take months in the normal excavation. And sometimes in the traffic it's not even possible. The pure time of curing you see here, in a small diameter, 100 meter, 3/4 of an hour. A big diameter, man entry, a few hours only. That means that thing can be done in a night shift. Start 8 evening, cut morning before traffic comes. We go in very high pore thickness with the glass, as you have seen in the sample. And this is coming, as was explained, thank you very much, from the design before. That means we need to understand what are the loads. Then there is done a normal design as per standards. And then we determine the thickness of the glass fiber to produce the pipe accordingly.
How many years validity?
There is a must of proof of minimum 50 years life cycle. The experience in the products in the technology group is around 40-45 years now. In glass fiber, 35 years. So, and we know we renovate pipes which are only concrete pipes, clay pipes, 30-50 years old. And the worst are those ones who were constructed 1975 up to 2005. Because before they were laid by hand in the soil with sand and filled very, very human, very moderate. But in the 70s, the big compactor machines came, and I claim that 60% of the pipes which we renovate nowadays are killed at construction stage. They get the cracks, the micro cracks, already when they have been constructed. Because the demand was only a layer of 30% sand over the pipe and then compact. And that compactor weighs 700 kilo, and they go with vibration over the pipe. And we see the cracks. Now we see with CCTV. But that time we have no CCTV. No one checked. We looked through, okay, we see the light on the other end, it's all okay. It was not okay. This is a few examples of larger pipes. The limits, we can, with UV cured lining, can only do straight pipes. We cannot go through bends. The limits, of course, are the size. The question why? Because when we pull the light train through, we would touch the soft material with the cable, and that gives an imperfection. That's why we are limited with straight pipes only or with no bends. At the point of a bend, we need to have a pit or start fresh when there's an access bend. The material itself is stupid. It doesn't know the shape. The pipe knows the shape. The material knows only the circumference. It can be box, it can be circular, it can be oval, it can be whatever. It knows the circumference. It follows the circumference. That means what we do at the end, we measure the circumference, we make the material like it, and then it's inserted, lifted up with air. There's a tolerance of about 10%, because sometimes we have variance in the pipe here and there. So we make an under dimension in the material with a surplus of the wall thickness, which we calculate. Then we can expand to the nominal real actual nominal diameter, still surplus in wall thickness to be safe. And then you can stretch up another, depends really on pipe, wall thickness and so on, size, 6-7%, 6%, and then the glass fiber is in force. Then there is no more expansion. The picture on the right side, by chance, circumference of box and circular was the same. That's why it's looking like this. But it's one pipe through, one liner through. The machine is a computer-controlled unit with a cable inside, and once the liner is filled with air and it's inflated with the light train inside, the operator starts the button, and the light train pulls with the control speed as per the wall thickness and diameter the light train through the material, and then you get out what you have soft, getting into the hard new pipe. Everything is documented. Actually, there's a camera inside to see the shape and the appearance of the product when it's still soft. That means we see what we get. After cleaning, there may something fall down still, there is some forgotten or here and there. So, and the liner is pulled through, inflated, but you see the hump, you see the here and there, and it can still be decided, cure it or not. After this is decided, they start curing, and the machine does the hardening of the material. All data like pressure, temperature, speed are controlled, monitored, can be checked out. We call it total quality management because normally QM system ends at factory door. The supplier normally provides good, whether it's a TV or whatever, or car tire, factory door, this is end of the quality cycle, done. So, go out of the door, done. We have the ability to scan with a QR code on the soft material, on the box, into the machine, and the machine knows the liner. It knows the speed, it knows what to do, not the operator anymore. You scan, and the machine knows, okay, this is liner 1.7 meter, this is this wall thickness, I need this speed. You say start, and the machine goes. That helps us in the elimination of simple errors, simple mismatch. Also, this is, of course, documented every second in the data. You can protocol, and at the end, you have one element from the first batch of resin, the glass fiber, into the making. We also control and scan in each product which we operate in the factory until the final product. We have a full cycle of all parameters. That helps us to eliminate failures in the early years, because otherwise there are always three opinions. What was the reason for a failure? You say this was this, I claim this, Yasin said this is the other one. We may go for Yasin, but Yasin was wrong. So we make it even worse. So data helps us to control and find root causes. We are on the side, something may happen, and we need to identify to stop a further similar error. This is the QR code scanner. If you are more interested, you have a booth there, you can go deeper into. Important for the asset owner, there was a question before about the quality. and the duration. There is an additional abrasion layer inside, because normally each product has an abrasion test. It's all good. We know of the so-so time abrasion is this. We say there's something wrong, because we say that we need a static design thickness, but we allow abrasion goes off. There is only one product, as I know, who considers scratching and make a reserve. This is PE pipe that is pulled in as a slip lamp. There is no other product I know who considers an additional safety for the abrasion to protect the full static wall thickness. And this product, the Alpha line, is the only one in this sector to provide that safety. As an additional layer for abrasion, like a sandwich. Resin, like we have it here, we guarantee 6 months of a storage time, but we know it's after 1.5 years still good, because we are not even in the Middle East. We work in Abu Dhabi since many years. It's 50 degrees in shade, so no issue. For very difficult environment or medium, we can use special resin, chemicals, outlet of industry, and temperature. 2016, the left picture was the limit, 1.2 meter. Now we are with, this picture on the right side is 1.9. Now we are with 2.10. What comes? So this is actually our size limit, 2.10 meter. One word to the IBG. We have a composite. We produce the glass fiber static layer, and IBG is doing the technology of the additional layer inside this one for the potable water operation. So it is a combi product of the two companies.
Thank you, Mr. Werner, for his nice presentation. So up to now we have had 2 great presentations. Now we will have the third and the last presentation. But this is focused not trenchless renovation, mostly trenchless installation.
It's both.
Both, okay.
Both.
So let me inform our audience that all trenchless technologies are environmentally friendly applications. So the trenchless applications do not guarantee zero excavation, but we guarantee minimum excavation. So these are very good solutions. For example, it doesn't create any traffic jams because there is no digging. So there is no risk for pedestrians. While you're walking, you don't need to, take care of the trenches. So you don't just jump in them. So there is no noise, or there is very minimum noise, and very lowered carbon dioxide emission. It is very important in these years. And one of the most important issue is it is very fast. So you can do hundreds of meters renovation or installation even in one day, while you can do the same with the classical or conventional digging methods maybe in 1 week. So these solutions all of them are very valuable. So thanks again to all of you to following this session. And I guess that we will see many great things also with Mr. Roger's presentation. Please.
Thank you very much, Yasin. My presentation just got 5 minutes shorter because you've already given some of the big advantages.
No problem.
Thanks. Right. You know that I'm not on the program, but thank you very much for attending my presentation anyway. I want to talk about traditional trenchless pipe renewal techniques, in particular pipe bursting. Oh dear. This looks different in my presentation because it just tells you that my name is Roger Wahl and I work for Tracto in the UK. Yeah, I don't know why this came out the way it is due to my contact details. But please see me at my booth, and you can gladly take one of my business cards. I hope to see you all there anyway. When I prepared this presentation, I came across a little graphics, which I liked, and I thought I'd share that with you, because Trenchless is still seen as a bit of a dark art. It's alchemy. It's not. People think it's smoke and mirrors. It's not. It is actually straightforward. Yes, it requires some know-how, whether it's the relining processes or our process, but it is actually a technique much like all the others, which gives you reduced community impact, gives you higher speeds, and generally less customer complaints. So I like this little diagram, and I thought to myself, that is really the essence of why we go to these conferences and exhibitions, because we learn about these things, we broaden our horizon. So yeah, thanks for taking the time to being here. As for all of the presentations are corrupted. So can I quickly?
Can we change the computer?
No, I just need the
PDF maybe.
no, I just need the HDMI cable. Just that. Yeah. Excuse me, give me one little second. Let's go back.
Okay.
I've got it on stick. Sorry, I just need to switch over to the stick.
انت مع الميديا ولا مع الترجمة؟
شو عم؟
انت مع الميديا ولا مع الترجمة؟
لا مع الكاميرا.
تمام. Yes.
ليش ما يكون كله عشان توفير؟ عشان يكون رسالة منظمة.
Doesn't matter, it's mostly pictures. Look, the font is it must be.
هم لا لا
بس يتغير.
TV is not working. The screen.
I'm sorry, just the camera. We are with the camera just.
Stagnation.
If you change
We open the floor for some questions.
Let's wait.
I was lucky. I had no.
Okay.
Okay. There's only one slide that is one more slide that's corroded, so it's not a problem.
Thank you for your patience. So we are on the way.
Yeah, thank you for your patience. So what I wanted to speak to you about is I wanted to quickly introduce Tracto, our product applications, have a little bit on pipe. Pipe bursting, a little bit on pipe bursting, the planning process, because in the bursting process it's just as important to plan as it is in the other processes. And then I wanted to quickly show you some of our solutions there, because we have several solutions to achieve the pipe bursting, and then show you one or two little impressions of job sites. Good. First of all, a little bit about Tracto. You can't read it here, but we're a German manufacturer of trenchless equipment. We have about 650 people around the globe. We were established in 1962. We're family owned, and we only produce, we focus solely on the provision of trenchless solutions. We don't do anything with trenches or anything like that. We are solely focused on trenches. We, now this is just racing on, which is nice. We manufacture, the best known product in our range is probably the Grundemat soil displacement hammer, but we manufacture, put this on. We manufacture horizontal drilling machines. Horizontal drilling machines from very, very small pit launch machines to surface launch machines. We manufacture pipe ramming equipment, and we also make pipe bursting equipment. It's the pipe bursting equipment that I want to talk about. We manufacture this, we produce this. Somebody's put this in continuous mode. So, presentation mode. The equipment can be used for the installation.
You should comment.
Yes. Okay, thank you. We can install pipes of any color, blue, green, yellow, whatever, water, gas, sewer, doesn't matter. Telecoms pipes, you can have in pipeline construction, connecting wind farms, whatever there is. We like to think that we've got a solution for that, and if you can think of even more, then come and talk to us, because we like to think that we're also innovators. But today is mainly about pipe bursting, and pipe bursting is only one of the many techniques there is for trenchless pipe rehabilitation. You've just seen two very, very good presentations on CIPP. There is many other techniques. All of them have got their place. All of them have got their advantages and also disadvantages. And all techniques offer specific, unique propositions that others can't. So when it comes to planning your job, it is key to have a good overview of all techniques. And it is key to think about what you want to achieve in your job. If you want to just reduce leakage and seepage, that's one thing. If you want to improve your hydraulic performance, or re-establish static parameters, if you want to achieve pipe realignment, or if you actually need to increase the capacity of your system. If the latter is your goal, then really it boils down to essentially two processes then that you can use. One is open trench, the other one is pipe bursting. Well, we've already heard about the specific advantages of pipe bursting. It is faster than open cut, and very specifically, it is less disruptive because you need a lot less excavation. And there's a gentleman in the US called Todd Grafenauer. He's the vice president of Murphy's Pipelines, and he's been in the Trenchless Technology magazine in 2020 with this little diagram showing that if you want to install 500 meters of new pipe in an open cut method, you will have 170 cubic meters of excavation. If you can't store that, for example, in a inner city urban area, what do you do with it? You need to transport it off. You need to grab lorry and take it away, and of course bring it back again. 170 cubic meters. That'll be, well, roughly on an 8-wheel grab lorry. That'll be around about 18 journeys. Do this trenchlessly with an entry pit, an exit pit, and 4 intermediate pits where you've got services that you need to reconnect. It is only 15 cubic meters of excavation. You need 1.5 grab lorries. There and back, still 4 journeys. So significantly less disruption, significantly less inconvenience to the general public, less management of the site. All in all, the better solution if it can be applied. And you need to ascertain whether you can use pipe bursting by asking this set of simple questions, really. What is your hose pipe? What is your existing pipe? What profile is your hose pipe? What's the hose pipe material? What is the proposed dimension of the new pipe? And what new pipe material do I need? What's the cause? Is there any bends? Is there any branches, lateral connections? Is it under a walkway? Is it under a road? Is it under something else? All of these things are important. What's the depth of the existing pipe? Is there any infrastructure around it? These become more and more important the bigger you want to upsize your pipe that you want to install, because you are displacing the surrounding ground. What are the ground conditions? Am I above the water table or below the water table? What's my side access? What are the pipe layout arrangements? What are the pit arrangements? Are there any manholes? Manholes are not necessarily a problem. Sometimes they're part of the solution. What's the reason for the replacement? Crack, corrosion, deformation, breakage? Have there been any previous repairs, any previous rehabilitation? Is an inspection possible? Can I put a CCTV camera? And most importantly, from a contractor's point of view, have I got all my permits to do the job in the first place? So once I've determined all of this, and I've come to the point where I say pipe bursting is possible, because much like the CIPP, we cannot go around bends, we cannot do 90-degree bends, we can do a little bit of directional variation, but we like things best when they're in a straight line. Once I've determined that pipe bursting is possible, then the vast majority of jobs are actually carried out using a process called static pipe bursting. Static pipe bursting is actually quite straightforward. You have a pipe bursting rig that goes into the entry pit. It's driven by a hydraulic power pack. With that pipe bursting rig, you push out the rods until you come to the other side. You install an expander to the other side, put your product pipe on the end of the expander, and simply pull the product pipes back. This one is blue, it might as well be yellow, it doesn't matter. We don't mind which utility we're working for. So, with regards to the materials that we can burst using static pipe bursting, well, the list is relatively long. Stoneware, concrete, reinforced concrete, cast iron, ductile iron, asbestos cement, fiber cement, PE, PP, PVC, glass fiber reinforced plastic, steel, liners, PA12. So virtually anything that you find in the ground. The new materials that we can install, the list is a little bit shorter. It is, a lot of people nowadays just install PE, but you can install PE, PP, PVC, glass fiber reinforced plastics, ductile cast iron, steel, stoneware, concrete. Now the latter few suggest to you that it's not only coiled material that we can install, but it's also short section pipes, and there's actually various attachments that allow us to just clamp together pipes, for example stoneware pipes, and just pull them in. Our range is from 20 ton to 250 ton pulling forces that allows you to pipe burst anything from 2-inch to 40-inch, so from 50 mil to 1 meter in diameter. And the key to the application is that we install a brand new product pipe of smaller, similar or identical, or indeed larger diameter into the existing pipe. So for every material there's a different bursting head, a different expander. This is a four-fly cutter to burst PE pipe, because believe it or not, PE pipe is already being burst because they've come to the end of their life cycle, probably through long installation. I agree with you there. We can use a roller blade where, for example, when you burst a ductile iron, you use that, or if you burst a cast iron that has been repaired very often, you can use the roller blade to cut through the repair clamps. So for every single material there is a specific attachment, a specific bursting head that allows you to get through that material. This is a setup. The entry pit is quite simple, but it is important to remember that you're pulling a piece of pipe through with essentially brute force. So you need to have a good abutment the other side, on the side where you're pulling, to make sure that it doesn't pull the machine into the ground. Whether it's I-beams here or railway sleepers, whatever you can think of, but it's got to be, and this comes with the experience of the contractor. It is very straightforward and simple, but it's essential that the abutment is enough to take the forces this machine can generate. Once the machine is installed, you push out the rods, and tractor specific are the so-called ladder rods, where you don't have to screw together the bursting rods, but you simply take them and essentially click them together. Very, very straightforward, especially on the smaller rigs where you can handle the rods by hand. It is very quick, but even on the larger rigs where you need the 250-ton rig, for example, where you need the help of a little crane or an excavator to handle the rods. It is straightforward and also gives you directional stability. So you don't have to be dead straight. It can cope with little bends, and I've got a nice little picture later on in the presentation. And here is a typical bursting head just before it goes into, it disappears into the hose pipe, which of course is still in the ground. Now this is a little job. I was looking for some jobs that we've actually done in the region, and this pipe burst was actually done with our smallest pipe bursting rig, 40-ton rig, in Rabat in Morocco. In the old town of Morocco, and you can see the restrictions that we had there with regards to space. The pit was only 2.5 meters long. The pipe was bursting 600 millimeter clay pipe, 60 millimeter clay pipe over 60 meters. But as you can see, it is not a straight line that we were bursting through, but extremely tight conditions. And that job was completed in 7 hours from start to finish. So yes, one of our key USPs, unique propositions, is that we can upsize. We can install a larger pipe in an existing hose pipe. Most pipe bursts are like for like. So a 300 millimeter ID in a diameter pipe is replaced by another 300 millimeter ID pipe, but we can double the size. We've even gone more than double. We have got some product specialists in Tractor who will gladly advise you as opposed to consult. No consultancy, but we can gladly advise you how to achieve. And if we believe that the project that's proposed is unachievable, then we will also tell you. We are not in this game to prove that our technique can't do it. We would like to succeed with you. So that's the big advantage of bursting on some of the other processes. We have got some disadvantages. I will not lie to you. For example, mostly, we also don't care what the hose pipe looks like. But what ends up in there is mostly round, no other shape. So it is a challenge, yes. We can do smaller. We can do relining, pulling smaller PE pipes generally into existing hose pipes, and we like to also put some cleaning heads in front of our bursting heads to make sure that every corrosion or damage or solid pieces that are in the pipe are cleaned out before we pull the new pipe in. We have got the ability to recalibrate the shape of the pipe that's in the ground. So if it's if you have slight damages or validity, we can send the calibration head through to make it perfectly round again before we put the new asset into the ground, the new pipe into the ground. So there's very many ways. We've also got the ability to do standard swage lining with a pipe burster. So that's static pipe bursting. The other proposition that we do have is a process that we call dynamic pipe bursting, which is often a lot easier and cheaper, which is far more forgiving for directional changes, but it has got some very specific drawbacks which make it really a niche application. So let me show you how it works. First, you put a little cobra through the existing pipe to attach it to a constant tension winch and pull a winch cable through until we get back to the starting pit. Then you attach a pneumatic hammer in an expander head, and attach to the expander head the product pipe that you're looking to pull in. And then the pneumatic hammer pushes the pipe, pushes the machine with the expander head through the pipe. The winch makes sure that the hammer, the force is transmitted in one direction, forward only. Very, very simple, very straightforward, but, and here's the big but, you've got a limited amount of materials that you can burst, and most importantly, the pneumatic hammer inside requires pressure air and requires lubrication, and it exhausts compressed air alongside a very, very fine oil mist. So in clean water pipes, this is problematic. In fact, in Europe it's not allowed for clean water pipes. It is something that is often used in wastewater, in sewer pipes. You also have limitations with regards to the sizes, because the hammers need a certain diameter, and they go up to a certain diameter. It is between 6-inch and 22-inch that you can do with dynamic pipe bursting. And very crucially, you can only burst brittle material. So concrete, reinforced concrete, stoneware, cast iron, PVC, asbestos cement, fiber cement. No ductile iron. It is a much more limited range of materials that you can burst. You can install PE, PP, PVC, steel pipes, install sectional pipes, that's not a problem. But also, very crucially, with it being a compressed air system, you must be over the water table. You cannot work under the water table. Water and dynamic pipe bursting don't mix. The water gets into the machine stops. Right, we've been hearing about quality control and quality assurance. We install a new pipe into an existing pipe. Obviously, your customers, or if you're the asset owner, you want to know that this pipe has been correctly installed. So we can install a load cell between the bursting head and the actual pipe that we're pulling in, that measures the actual forces that you're pulling on the product pipe. And once the pull is complete, the load cell can be taken out, and the information can be downloaded to show that you haven't, for example, overstretched the pipe. Shouldn't, because the real forces don't end up on the product pipe. They are on the bursting head, on the expander. So that really concludes my little bit on the installation of new pipes into existing pipes. And if you found that interesting, then I invite you to come to see me on my booth. I'd talk to you more about this. Any questions? Yeah. Thank you.
Thank you for your nice presentation. Actually, I would like to thank you all for your excellent presentation. Now it's for question and answers. Before you ask your question, please introduce yourself, your name, your company, and which country you're from. So, okay, the lady, the first question.
Thank you, Professor Day1, Vice President of Israel University for International Affairs, Dean of Faculty of Engineering. At first, my deep condolences for our friends in Turkey for the earthquake. The question for Engineer Lutis. Have you checked and take under consideration the pressure hammers for the design of the pipes?
It's a part of the design.
You have done it? And the dynamic stress loads due to pump cycle also? You check both of it?
Yeah, there is a design standard for it, so it allows for it. So whatever you have on values, you can determine that and put that in the design.
Okay. For Engineer Werner and for the other engineer, because your name is not written.
Roger.
Your name is very difficult for me. It's German, I think.
Yes.
I think that we should add for the simple project checklist earthquakes. You should add the abilities of resistance concerning the movement of the earth and of the land through earthquakes. And this is the new thing. Because you are working in Turkey, earthquakes nowadays all over the world, and if you want to be updated, this is a very important issue. Concerning the maintenance also, I have a question for you. It's not easy for the maintenance to be for the maintenance. If there is anything happens, if you the life cycle will say that it's 50 years. How can we fix any problem?
So,
This is two questions. The first one to add earthquakes and resistance to earthquakes and earth movement. This is very important. And if it is not, we should put it, all of us, under consideration for all the new technologies and tools nowadays. The other thing is concerning the maintenance of the material if something happens.
About the earthquake, the CIPP systems have actually developed in Japan, and nowadays we have a factory in Japan, actually 2 factories, and we produce especially for earthquake protection. That means their liners are designed differently, they are stronger in the wall thickness. There's a standard in Japan for earthquake of CIPP glass fiber reinforced UV liners. And they use it constantly as a program to refurbish existing pipes. And what they do now, when they make a new construction, they do a very simple, cheap concrete pipe, even no socket, just in the ground, and line it from day one with GRP UV liner to have the earthquake protection of the, because the liner is stable, but it's not brittle. And it's overcoming, let's say, movements of the earth. There's a program, this is obligatory in Japan, that this can be only lined after this Japanese standard. I have a copy, it's in Japanese. The other question, the usage, what is it? It is the normal flow and medium which is going through, and it's the cleaning. What we should not do is, and it's actually not necessary, cleaning with scrapers. That is not necessary. That would be too much. But the jet cleaning is a normal maintenance. Other than that, if you have a connection or go into it, you feel as like also any of your pipes, like a normal pipe. You cut it, you mount whatever you want, a connection to it. It's GRP, or it is whatever material you have.
Yes, with regards to earthquakes, I've seen a picture from Turkey where a new canyon has been created. No material, the standard earthquakes that much. But from my side, the solution is also to use materials that are more forgiving. HDPE is the obvious material. With regards to maintenance, as I said, part of the possible applications for bursting is to reinstate previously damaged pipes by sending a calibration head, we call it, through the pipe, and then depending on the rate of damage that you have, reline. From my perspective, the best maintenance sometimes is just to replace what's there with something new. And if you can't reduce the diameter, then that is the nice thing about bursting. You can just install exactly the same diameter again. But there's a whole group of different every proposition is different, and the advantage that we bring is that the machine can do from smaller diameter to much larger diameter across the board.
Any of the three are currently in Jordan?
Operating
in Jordan? Is there operation in Jordan, in my country?
I'm sure some of our customers have operated here, but we are the manufacturer. We're not the contractor.
Excuse me. Yes. Okay, before your more questions, let me ask the other people if they have questions. Then if we have time, then I can give you the word again. Any more questions?
Yes, please.
Okay, I have two questions.
Your name, country.
My name is Engineer Arwa from Yemen. Yes, we are head of urban water and sanitation project implementation. So we have two questions. Maybe I am interested more in implementation. So this is very good presentation. You give all these advantages, but we need now to know something about disadvantages or the challenge during the implementation, during the maintenance. If there is any problem during the implementation, during the 15 years of the, is there is any problem, how we can maintain such a kind of technique alignment. Also, we notice here all the bit. We are in Yemen, for example, in some very old city with a lot of services like electricity and water, and all of them in the same places. So we need here to know if we want to use that such a technique, how we can manage the other services. I think this is it needs special circumstances. This is one thing. Even there is a different methodology. For example, some places is soily, other places is stormy, and how we can use the same technique as there is any other equipment, one for the stone, one for the hard rock, one for the soil, and there is no fall down during the excavation.
Can I give the first part of the answer? That is one of the disadvantages of pipe bursting. Even when you replace like for like diameter, you are always displacing soil. You are displacing the old pipe into the surrounding soil. And that is important. You need soil or a material around the pipe that allows for that displacement. So if a pipe has been laid into concrete, for example, that can't be displaced. So that is a no-no for our process. This is a problem that you guys don't face. And also, depending on how much you upsize, there is rules of thumb how far away you need to be from the other services to avoid damaging. That is where planning and the knowledge of the surrounding infrastructure, our bursting process is probably more important than it is in your lining processes.
Another thing, so you want to enlarge even. So how I cannot imagine how I can enlarge. So I have specific diameter and things to enlarge.
It is impossible. It is the application of brute force. As long as you can get the bursting rods through the pipe, we can put a larger bursting head or expander, whatever you want to call it, on the other side, and it follows the path of the existing pipe. It breaks the existing pipe open, it cuts it
How you
open.
can get it out?
You don't need to get it out, it stays in there.
Keep it in the.
You just displace it into the surrounding.
To the surrounding.
Yeah, it stays in
the
there.
soil.
Stay inside.
Yeah.
With specific pipe materials, there is a slim chance that you can recover some of them, but that is very, very specialist and not very reliable. Normally, we just displace and more or less forget about it.
To make a comment here, Trenchless technology is not a magic, but you have to experience it. You can follow several conferences or several presentations, but the best way is if you have a difficulty or if you have a case and if you want to apply this solution, maybe you can try to have a pilot application. So all the companies can make their best to introduce their solutions to you in a real case or maybe in a pilot case. So there are several different situations. So one solution can fit one problem, but it may not fit to another problem. So all different techniques have different advantages and different disadvantages.
We come here especially to learn.
Yeah, so
This is for us strange.
We can talk at the booth later. I can go more into detail. Just to answer part of your question just briefly, the limits in CIPP lining is the size, it is the no bends, and at one point we are limited with what shape we can do, which makes sense. So if it is too late, it's simply too late. Most important is to have trained crews on the site because the material is half ready, as you have seen. And this is something where we more and more survey that we have trained individuals, not the company is trained, and they change the people, that the individual are trained and they know what they do because they bring the good ready into the new pipe. So other than that, I'm 34 years in this lining business, and I look back, it's about 4,000 kilometers so far under my responsibility, either installation or production. And I have not seen many failures over time, which was not like into digging in when you, but any other type breaks when you go with a
Okay, I think just one final comment. I think I speak for all of us in this Trenchless industry. We know that we've got some excellent solutions that can cover a wide range of situations that you might have, but we also know that we have limitations. And I think none of us, because people think the dark art and stuff like this, none of us are in this business to prove that we cannot do it. If we believe that a job can't be done, we will be open and honest with you and say, it can't be done without method. Because we don't want, we don't need people to say, Trenchless, famous. No, we don't need that. We firmly believe, and I think I speak for all of us, that Trenchless is the future. And there's going to be more and more trenchless as opposed to open cut digging. And we all have a vested interest in bringing the whole of the industry forward, even if we have different methods.
We are in, since about 15 years in Singapore in the frame contracts, they do since 1990, 1995, constant, as Istanbul is doing, rehabilitation of existing pipes. Not because they are close to collapse, because then it's too late. I'm very sorry, then it's too late. It's as a prevention And I had a discussion with the director in PUB, which is the authority in Singapore, and he made a simple calculation, and you can do that in the afternoon on your own. He said, how long? You asked, what is the life cycle of a new GRP pipe? He said, how long do our pipes in the ground last? 100 years? 200 years? Sure not 300. 70 years already gone. Simple calculation. You may decide on 200 years, but make the calculation. For a simple case, take 100 years of an average life cycle of a pipe. That means a city per 1,000 kilometers need to do 1% every year, which is 100 kilometers, 10 kilometers, sorry, of rehabilitation. So if you decide it's more, you decide it's more. But the practice shows, if you wait too long, the future generation can no more, that is what he said to me, we shift our problem into the future generation, they can no more handle it.
Okay, thank you. We need to close the session because of the preparations for the next session. So before closing the session, I would like to thank special thanks to our simultaneous translators for their great efforts. And one more announcement that today you followed 3 great presentations, and tomorrow morning, 9 a.m., there will be another transit session, including 3 great presentations. It's session 10 in room Astor B. Okay, have a nice day.
Thank you.